I hope everyone had a good Christmas break. Had a lot of time off. It's been a while since we've had a flip video. Good thing is that we start off with a pretty easy one. Most of us are pretty familiar with the Pythagorean theorem. Again, I've got a right triangle, so I could take a squared plus b squared and it equals to c squared. Whether you know exactly what you're talking about when you say that, all it means, I can take the area of this square, a squared, the area of this square, b squared, the area of this square. If I add them up, it has to be equal to the area of this square, the c squared. So that's basically where that thing comes from. But again, a squared plus b squared equals c squared. You don't have to memorize that. It's on your formula chart. Okay, Pythagorean triples are nice because they can save you some time if you can remember some. All it is a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. For example, one famous Pythagorean triple is 3, 4, 5. Because if I do 3 squared plus 4 squared, that's 9 plus 16, which is 25, which is equal to 5 squared. So if I know that this is 3 and I know this is 4, I don't have to do the Pythagorean theorem. I already know that that's 5 if I can remember a Pythagorean triple. Alright, so here's some examples. Now the only thing that's different about these and maybe some of the other ones that you've done is that, like we did in class the other day, you cannot give me a decimal answer. Your answer has to be in radical form, has to be in simplified radical form. That's why we spent so much time in class the other day practicing that. Okay, so here's my right triangle. So I can take this one squared plus this one squared equals this one squared. A squared plus b squared equals c squared. So I have 2 root 7 squared plus root 35 squared equals x squared. Again, Pythagorean theorem. This one squared plus this one squared equals this one squared. Well, 2 root 7 squared means I got to do 2 times 2. The numbers on the outside, 2 times 2, I got to go 2 root 7 times 2 root 7. I multiply the two numbers that are outside together and the two numbers that are inside together. So I can do 2 times 2, that's 4. And then root 7 times root 7 is root 49, and root 49 is just 7. So I'll take 4 times 7, which is just 28. So that's where this 28 is coming from. It's just taking 2 root 7 and squaring it, again, like we did in class the other day. Plus, the square root of 35 squared is just 35 equals x squared. So now I can take 28 plus 35, that's 63. So 63 is equal to x squared. I want to know what x is, so I square root both sides. So square root 63 equals the square root of x squared is just x. So now I got to simplify this. I got to be able to simplify the square root of 63. But I recognize that 9 is a perfect square and it goes into 63. So I rewrite square root 63 as square root 9 times square root 7. Because square root 9 times square root 7 is the square root of 63. They're the same thing. But I can do this one. The square root of 9 is just 3, so that can come out of the box. And the 7 stays inside the box. So my answer is 3 root 7. Okay, this one, they give us an isosceles trapezoid. We'll talk more about isosceles trapezoids in a few weeks. But basically, they said, okay, this top piece is 12. Then they drew these lines straight down. These are called my altitudes or my heights. And it's 22 all the way across. Well, if it's 12 from here to here, it means it's 12 from here to here, which means I need an additional 5 here and an additional 5 here if it's 12 in the middle. And if that part is the part that's confusing you, don't worry about it, because again, we'll talk more about these, a lot more, in a few weeks. Okay, so now I want to know what this x is. And this right here is another famous Pythagorean triple. This, again, I can look at it, and most of you guys in a week or so will be able to look at it too and know the answer is 12. Because 5, 12, 13 is another famous Pythagorean triple. But let's do the work, assuming we didn't already know that. Okay, so 5 squared plus x squared equals 13 squared. So a squared plus b squared equals c squared. Gives me 25 plus x squared is equal to 169. Subtract 25 from both sides. X squared equals 144, and x is equal to 12. Okay, this one, let me go here. So again, same thing. A squared plus b squared equals c squared. So I have 2x squared plus x squared equals 225, because that's 15 squared. Well, 2x squared plus x squared, 2x squared means I got to do 2x times 2x. So 2x times 2x is 4x squared. I just brought down the other stuff, plus x squared plus 225. Well, 4x squared plus x squared is 5x squared, and I still have the 225. Divide both sides by 5, and I get x squared is equal to 45. Square root both sides, and I get x is equal to the square root of 45. Again, I have to be able to simplify this. I see this one again. 9 is the biggest perfect square that goes into 45. So I rewrite 45 as 9 times 5. And I know the square root of 9 is just 3, so that can come out of the box. And so my answer is just 3 root 5. Okay, and the last one on this page. Okay, a squared plus b squared equals c squared. Again, so x squared plus 6 root 2 squared equals 10 root 2 squared. Bring down my x squared. So 6 root 2 squared means I got to take 6 root 2 and multiply it by 6 root 2. So again, the two numbers on the outside multiply together. So 6 times 6 gives me 36. The two numbers on the inside multiply together. So that's root 2 times root 2, which is root 4. And the square root of 4 is just 2. So 36 times 2 is 72. Same thing over here. So 10 root 2 squared means 10 root 2 times 10 root 2. So 10 times 10 is 100 times the square root of 4, which is just 2. So 10 times 2 is 200. So now I can subtract 72 from both sides, and I get x squared is equal to 128. Square root both sides, and I get x equals the square root of 128. Okay, a little bit of thinking here. I got to figure out what's the biggest perfect square that goes into 128. It's 64. So I can rewrite 128 as 64 times 2, but the square root of 64 is just 8, and I bring down the root 2, so it's just 8 root 2. Alright, so here's some interesting word problems. They always like talking about ladders leaning up against the wall. It's like the most famous Pythagorean problem there is. So I got a 15-foot ladder leaning against the house, and the base of the ladder is 9 feet from the house. How far up the house did the ladder reach? So we tried drawing a little picture. It doesn't have to be pretty, just accurate. So there's my 15-foot ladder leaning against the house. This is the house going straight up and down. It better be going straight up and down if it's a house. And it says that the base of the ladder is 9 feet from the base of the house. So this is 15, this is 9. I do a squared plus b squared equals c squared. Right there, simplify it. 9 squared is 81, 15 squared is 225. Subtract 81 from both sides. X squared is equal to 144, and x is equal to 12. That one's pretty straightforward. This one required a little bit more thought. Okay, I got a flagpole that was originally 24 feet tall. So my flagpole was 24 feet tall. It cracked though, so it's not still standing 24 feet tall straight up. It cracked 9 feet above the ground. So, you know, my flagpole was going straight up and down like this, and it was 24 feet. It now cracked and is like leaning down like this. So it's not straight up and down anymore. Okay? And it cracked 9 feet above the ground. So find out how far from the base of the flagpole, the top of the flagpole, touched after it had fallen. So this is what it looks like. Okay, so here's my flagpole. My flagpole is this piece, the piece that's still standing straight up, and then this piece that's now hanging down. Well, it said that it was 24 feet tall. Well, it is 24 feet tall. So if it's 9 feet, if that piece is still, the piece that's still sticking straight up, if that's 9 feet tall, because that's what it said, then this piece, the piece that's leaning over, it must be 15, again, if the flagpole was 24 feet tall. Because if I take this 15 and I stand the flagpole back up, it should be 24 feet. But again, it told me that it was 9 feet still standing and the rest of it was leaning over. So that's what my picture looks like. And it should recognize it. It's the same problem we had in the last one, which is kind of funny. So x squared plus 9 squared equals 15 squared. X squared equals 144, so x is equal to 12. So it's this distance right here. Alright, Pythagorean inequality theorem. So we've been talking about if it's a right triangle, then a squared plus b squared is equal to c squared. Okay, but what if it's not a right triangle? What if this is true? What if the a squared plus b squared is not equal to the c squared? What if the a squared plus b squared is bigger than c squared? So if the a squared plus b squared is bigger than c squared, it means it's an acute triangle. And if the a squared plus b squared is less than the c squared, then it's an obtuse triangle. And you'll be given problems and asked what kind of triangles that you got. So this is the first one. It's 8, 11, and 13. The first thing you should do is check, can you even make this triangle? We talked about this last semester. Think about it for a second. Yes, I can make this triangle. So now I got to figure out what kind of triangle it is. So I got to see what's true about the a squared plus b squared and the c squared. If the a squared plus b squared equals to c squared, it's a right triangle. If the a squared plus b squared is smaller, if the a squared plus b squared is bigger than the c squared, it's acute. If the c squared is bigger, it's obtuse. Okay, first of all, you got to be able to figure out which one's the a, the b, and the c. A and the b don't really matter. You can sort of interchange those. The important one is the c. The c is the hypotenuse, and the c is always the biggest side of the triangle. So my 13 has to be my c in problem A. So now I'm going to take a squared plus b squared, 8 squared plus 11 squared over here, and here's my c squared over here. Now I got to figure out what's true about these two sides. Okay, so I take 64 because 8 squared 64, 11 squared 121, and I squared 13, get 169. So now I get 185 over here. My a squared plus b squared is 185. My c squared is 169. Which one of those is bigger? This one's telling me that my a squared plus b squared is bigger than the c squared, which means I have an acute triangle. Okay? This one requires a little bit of thought. Again, you got to be able to recognize your c, which one's the biggest side. If you don't know what's bigger, 3 root 3 or 6, just put 3 root 3 in the calculator. It's smaller than 6. So the 6 is my c, my 6 is my hypotenuse. So I have a squared plus b squared, and I have my c squared over here. Again, I'm trying to figure out which one's bigger. Simplify this set. 3 squared is 9, 3 root 3 squared is 27, 6 squared is 36, 9 plus 27 is 36. I still got 36 over here. So this case, my a squared plus b squared is 36. My c squared is 36. So what's true about these two? They are equal to each other. My a squared plus b squared equaled my c squared. So I have a right triangle. And the last one, 7, 12, 16. Again, the 16 has to be my hypotenuse. It must be my c. It's the biggest side of the triangle. So I take my a squared plus b squared over here. I take my c squared over here. And I'm trying to figure out what is true about these things. Which means that 49 plus 144 is my a squared plus b squared. My c squared is 256. So I have 193 over here, and I have 256 over here. So my a squared plus b squared, which is 193, is less than my c squared because that's 256. So again, when my c squared is bigger than my a squared plus b squared, it means it's an obtuse triangle. Lots of examples to follow in class.